So today we will solve the problem. Today we will solve the problem, traveling salesman problem. Okay. Uh, if I tell you that this problem is a hard problem, and what do you mean by NP hard problem? Is that there doesn't exist a linear time complexity solution for this problem till now. Okay. So although we have just find the solution using TP with bit masking, or another solution can be fully brute force, that we try all the permutation, that is n factorial again, which is not polynomial time complexity. So let's see how this problem can be solved using DP with bit masking. So now first I will code and then make you understand parallelly. So I am defining the state. Okay. So DP with bit masking. Before going to the solution, let's discuss the problem first. So we have been given a matrix cost of size n, where cost ij denotes the cost of moving from city I to city j, and our task is to complete a tour from the city 0. We are following zero based indexing to all other cities, such that you visit each city at most once, and then at the end come back to the city 0 in minimum cost. So we have to start from the city 0 and traverse through all the cities at most once, means we can traverse to other cities also, or we cannot, and finally we have to return to the city 0. And now finally we have to return the minimum cost to do this tour. Okay. Suppose for this example, what do we mean by the cost matrix? Has been given that it is 0, it is 0, it is 1, it is 112, it is 112, and it is 111. Okay. So it is 0, it is 1, it is 0, it is 1. Okay. So the distance between 0 and 0, city 0 from city 0 is 0, city 0 to 0, city 0 to city 1 is 111, and city 1 to 0 is 112, and city 1 to 1 is of course 0. Okay. So now we have been given the cost of the tour. We will go from city 0 to city 1, and what is the cost? It is 111. Okay. So 111 plus, now we have to return to the, since we have traversed all the cities, because only two cities were there. Okay. So that's why we have to return now. We would have to return from 1 to 0. So what is the cost from 1 to 0? It is 112. So this is the cost. Similarly, this example also. Now let's move on to the solution. So I am defining first states of the DP. What DPI state will denote? uh, what is mask? First of all, mask, through mask we will store, uh, we will keep track of which cities are already visited and which cities are uh, yet to be visited. Okay. Suppose 5 cities are there. Okay. 5 cities are there. Also, how do I know that it can be solved using DP with masking? Because you can think, you can observe the constant, it is uh, less than equals to 20. So if you find a question where constant is very low, basically means you can say 20 or 16, and is less than equals to 20 or 16, then you can think of TP with bit masking or recursion or bit masking, this type of solution to exist in those types of question. Okay. Now suppose if 5 cities are there, so, and if I define a number, let's suppose it is 100, I am denoting with binary 10010. Now what does this number indicating is that it is, this number itself is called mask, and what does this number indicate? That it is representing the states, it is representing the state of the cities visited till now. means suppose since we are following the zero based indexing, so it is 4 4 3 2 1 1 or 0. So I have indexed the cities. Okay, so I have not visited yet city 0, because how can I tell that? Because this corresponding bit is 0. So if the corresponding bit is set, what does indicate that I have already visited that city and that city should not be visited again. Okay, here also you can see the city 2 is not been visited yet, and 0 is all 3 is also not visited, and 4 has been visited. So yeah, now let's talk about the state. dp of I comma mask dp of I mask will denote if I am at city I, if currently I am at city I, and this is the state of the visited cities which I have expressed using the mask, then what will be the minimum cost to complete the tour, that is this tour, to complete the tour from the city 0, and after all the traversal I have to return to the city 0. So what will be the minimum cost? Okay, let me write it. What is the minimum cost if I am at city I and mass denotes the state of the state of visited cities till now. Okay, so suppose now one thing also, if I consider that only 5 cities are there, then what is the mass, what will be the mass that I can confirmly say that I have visited all the cities and now no cities has been left to visit. Okay, so obviously it should be like this: 1 1 1 1 1, 5 ones. Okay, so what is this, what this number exactly? It is 2 to the power, it is 2 to the power 5 minus 1. You can check. 2 to the power 5 32, and minus 1 is 31, and you can see it is 31. uh, let's, if you have learned binary representation, then obviously it should be understandable. Now let's move on to the solution. That's the only prerequisite. Cost dot size. Now I will declare a function return solve of I. Initially the index is 0 because I am at city 0, and I have visited city already. I have visited city 0 because I am already at present city 0, so mass could be 1. What I mean is that 0 0 0 1. So this is number is 1, indicating that I have already visited city 0. Okay, now I will have to pass cost, and let's pass n. Okay, mass, which is representing the state of the visited cities till now, int n, and now vector of vector and pass it cost. Okay, so what should be the breaking condition? Suppose if I have visited all the cities and there is no other cities left to be visited, so I would have to return. So that would be the base case. And how to write that? If mass equals to 1 n minus 1. That's what I have explained now. 2 to the power 5 minus 1. If this is the condition, then I have to return. And since we have also been asked to again means again visit the city 0, means return to the city 0. So Suppose I am at city I and I have visited. After visiting this, I can say that all the cities have been visited, but also I have to return from the city I to the city 0 again. That's why it will cost you city of I comma 0 for returning to the city 0. I hope it's clear. Now I will go to every unvisited city and take the minimum of that. What I mean is that suppose I have declared an answer 1 in 9 plus 7. It's a big number. Okay. So what I mean is that I will suppose if I am at city I, now I will go to every city. I will try every city, whichever I can go, and will take the minimum. Means the minimum means the path which will result in the minimum answer. I will take that. Okay. So if mask and 11J continue. Why I have done so? If if that city is already visited, so I have not to visit it again. That's why I would have to continue. And if it is not visited, then I will do my job here. Answer comma cost of I comma j. Since I am going from city I to city j, so it will cost me cost ij and solve of j. Now the current city is j would be j and mask I will have to set mask j. Now I have also visited the city j. Okay, and cost. Finally, I will return the answer. So this is the recursive code. So what is the time complexity? If you can think of. So when I was explaining, you can see we are trying all the possibilities. Means we are trying all the subsets, all the permutations of the cities. Means in which order we would traverse the cities, so it will cost us the minimum for completing the tour. That's why, means suppose if 5 are there, okay, so I am at city 0. I can go to this, I can go to this, I can go to this, I can go to this. So I can go to this first, I can go to this first, or this first, or this first. So whenever I am at city, this will be the condition that I will have to choose to which city I have to proceed on. Okay, that's why, since each city has two options, either to be chosen at that instant or not, so it would be 2 to the power n options, 2 to the power n permutations possible. So this code is running for 2 to the power n, 2 to the power n permutations it is checking for. And one thing you should observe, that this this uh, this iterator is itself going from, means it will also take big of n, because each time I am going to each cities, so it will be n. And one thing, in each iteration I am running an internal loop for checking each cities. Okay, so it would be total n square into 2 to the power n time complexity solution. That's why I have said no. It is a NP hard problem, and till now there doesn't exist a polynomial time complexity solution for this problem. Okay, and but this solution would not pass. You would have to surely memorize it, because n squared 2 to the power n is surely much bigger, even if the n is less than equals 20. Because if n square would be 400, 400 into 20, 2 to the power 20, you can think of 2 to the power 20 as even greater than 10 to the power 6 into 400. Obviously it is greater than equals to 10 to the power 8, greater than 10 to the power 8. Obviously it would leads to really. So we would have to memorize it. Let's memorize it. So what can be the highest mask possible? And okay, so mask, initially I am setting all the entries as -1, and if dp of I comma mask is not is equals to -1, means what does this mean? uh, if when this solve function will be called, then it will first check if I am already solved this state, means when the visited cities was this and I was at currently at this cities, then I do not require to solve it again and again. That's why dp memoization is used. dpi comma mask, and whenever I am passing the returning the answer, then I have to also store it mask equals to this. So let's first run this code and see whether it's really fine or not. Let's submit it. So yeah, time complexity is n squared into 2 to the power n. I have already explained, because this this loop will take a big O of n, and this internal loop will big O of n, and itself this it will check all the 2 to the power n permutation. 2 to the power n permutation. So it would be n squared into 2 to the power n. And talking about the space complexity, you can see here that I have stored a mask whose value can differ from 0 to 2 to the power n. 2 to the power n. That's why it's 2 to the power n. And also I have created, when the I have defined the state, I have also created dp of I comma mask. So this entry is also taking big of n. So it would be n into 2 to the power n. I hope it's clear. So n into 2 to the power n is space complexity.